All right, we're back. Chapter 12, we begin now, and we're going to, short chapter by the way, only 5 sections. We're going to be talking about sequences, series, those types of things. Now again, the first thing we're going to look at here is just kind of making sure that we know that a sequence has a limited set of numbers. And again, we're going to be looking at patterns as we do some of these as we go on here. And one of the things that we had with this Fibonacci sequence, kind of an interesting type of thing. What you'll notice is that the first term is 1, the second term is 1, and then to get the next term, what you do is you add the 2 previous terms. So 1 plus 1 is 2. And then to get the next term, the fourth term, you add the second and the third terms. 1 plus 2 is 3. To get the fifth term, you add the previous 2. 2 plus 3 is 5. So we say that that's kind of a recursive formula because you're not putting numbers into an equation. What you're doing is you're taking an answer that you get out and then putting it back in. All right, so let's kind of talk a little terminology as we go here. We know that we have this. Whenever we have a subscript, a sub n, we know we're going to read that as subscript. So just read a sub n. The first term would have a 1 there. We'd go a sub 1. We can go a sub 2, which is the second term. So the subscript really just tells you what term that you're working with. All right, we'll get familiar with those as we go. All right. So here we go. We have a recursive equation. It tells us here that the first term is a sub 1. That's negative 2. So that's what we're going to start with. So look at our table over here. Negative 2 is what we start with. Now, what we're going to do then to get the second term is we're going to take that first term and we're going to put that into here. So here's what this really says. This is the nth term. This is the n minus 1. So you think of it this as being the term you're looking for. This is the term that's previous, the one that's right before it. So we're going to take 3 times the previous term, and we're going to add 2. All right, so as we do that, 3 times negative 2 plus 2 is negative 4. Well, then you put negative 4 into there. That's the previous term. That's how you get the next term. And you can do this. Now, take a look over at the calculator here. Here's a real slick way of doing this. Put your first term in, negative 2, and then hit enter. All right, then what you're going to do is you're just going to go ahead and you're going to hit 3. But now in place of a sub n minus 1, what you're going to type in is you're going to hit second and answer. So the answer, it's a last answer function. So it takes your previous answer, puts it in, multiplies it by 3, and then of course we have to add 2. Now the best part about this, every time I hit the enter button, it gives me the next term. Look at that, negative 4. And then when I hit it again, oh yeah, there's negative 10, there's negative 28, there's negative 82. So whenever we have a recursive equation, we want to use that last answer function on the calculator. And you know it's going to be recursive if we give you the first term and you see something this with an a sub n and an a sub n minus 1, kind of meaning, hey, to get to the next step, take where you are now, multiply by 3 and add 2. And we can look at some other cases of that too. Let's go ahead and clear the screen on this, and then we'll go on to our next one here. All right, so now the next one here, you can see, once again, this is a recursive equation. We're told that our first number is 2. So on our calculator, we're going to put 2, hit enter. And then over here, we're going to take negative 3 times a sub n minus 1. That's our answer that we put in. So just go negative 3. And then all you have to do is just go answer, second, ANS right here. And then you should see the same thing hook up for the table there. Yeah, negative 6, 18, negative 54, there we go, and we keep going. Every time I hit enter, that's just giving me the next term. All right, so now, what if we have something where it's not a recursive equation? What if it is an explicit rule? Now, we're going to know that because what's going to happen is they're not going to tell us what a sub 1 is. They're just going to give us a formula here is what we're going to do. All right, well, and if that's the case, here's what we do. That's just by putting numbers in for n. So 1 squared minus 2 times 1. And then for the second term, you actually put a 2 in there. Notice the difference. This is what we call an explicit rule. So when you want to do this on a calculator, really easy to do this. Just hit the y equals, and then type in the formula there. Obviously use x's instead, x squared. And then let's go minus 2x. And in this case, we can just go ahead and hit enter, and then we're going to make a table. Second table, and there we go. So there's our first term, second term, third term, fourth term, fifth term, just like they have in the table here. So again, we want to use that whenever we're using explicit rules, where we're not given recursive equations. Notice the difference between the two. Okay, so again, we can do that for a couple examples. if we want to. There's plenty of examples that we have there. Again, explicit formula as we talk about that. Now, one thing to keep in mind, we might be asking you to come up with equations of those formulas. Now, how do you do that? Now, you have to kind of figure out, probably either going to be linear, quadratic, or exponential. Now, if it's linear, your first differences are going to be the same. The quadratics will have second differences that are the same. And exponentials, that's where you're going to multiply by the same thing. Okay, so those are going to be kind of the formulas that we're going to be looking for as we write some rules. All right, so here's one here as we take a look at 5, 10, 20, 40, 80. All right, we can tell here that the first differences aren't the same, nor are the second, but what we're doing is we're multiplying by 2. So whenever you're multiplying by the same thing, we can tell that it is going to be exponential. So what we want to do then to come up with the equation, a couple things that you can do. One is you can go into the stat mode and into edit. Now again, in list 1, go ahead and put the term down. Okay, so we have 1, 2, 3, 4, 5 terms. And then in list 2, actually put the numbers down, 5, 10, 20, 40, 80. Now to come up with the rule then, since we identified that it's exponential, is we go to stat, calc, and then you can just go right down, exp, got to scroll down a little bit. All right, should be coming up there. Oops, it went too many. All right, there it is, exponential regression number 0. We hit that. Go down and calculate. And bada bing, bada boom. There it is. All right, so it's going to tell us that A, that's our starting value, is going to be 2.5. And then B is the base, that's what we're multiplying by, that's 2. So 2.5 times 2 to the x would be the equation. Now again, we could have done that kind of in our head. We realized that the base of the exponent we're multiplying by 2. Where do you start? Now remember, this is the first term, so if we're going to write the equation, we always got to start at the 0 term. So the one before the first term, if we're multiplying by 2, would have to be 2.5. So our equation over here would be 2.5 times 2 to the x. All right, let's try another one that we have here. Let's see another example. Here it is. Now in this case, we see that our terms 1.5, 4, 6.5, 9, 11.5. When we do first differences, yeah, we're adding 2.5. Now, with a linear equation, we have to know two things. Where do we start? And what are we adding? And so we already have our slope, 2.5. So we'd say y equals 2.5x. And then, of course, we have to add the y-intercept. Now, again, that's when the term is 0. So you actually have to go before the first term. So we'd have to go 2.5 before this. We would say minus 1. So 2.5x minus 1 would be our equation. Now, once again, you could put that into the stat mode and then do a linear regression if you want to. That's certainly something that you could do as well. All right, now sometimes the pattern is there. It's not really conducive to put into the stat mode, but we certainly can kind of figure out the pattern is the first term is 1, second term is 1 over 2, 1 over 3, 1 over 4, 1 over 5. Well, if we wanted to find the nth term, obviously it's going to be 1 over whatever the term is. 1 over n would be our pattern that we have. All right. So there we go. Those are some introductions to sequences and series. Make sure understand the difference between recursive equations. That's where we're taking a number, we're starting with a number, putting it in. Whatever we get out, we're putting that back in. And then there's explicit rules where we're putting the term number in for n. That's where we use the table mode of the calculator, and should be able to get that. All right, you got worksheet 12.1. Work on that. Keys provided. Again, always let me know. Email me if you have any questions or thoughts. Okay? All right. Good luck. Until next time, I'm Mr. Boone.